All right, hydrazine. We want to actually figure out its proper Lewis structure. Good strategy on using on this. We're just going to eliminate the ones that don't actually follow our rules. So we're going to start by getting our valence electrons. And on this, we should get 14 valence electrons. Now, going around, and we're just going to put little letter down here to mark out which ones are done. Fine. All right, A has 2, 4, 6, 8, 10, 12. There's no way A is properly. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14, 16. All right, so A and E don't have the proper valence electrons. The remaining ones do. They do have atoms arranged in space. They do have all the lone electrons added out. What we're going to do is check the formal charges to see if we can figure out which one of these is right. Now, I'm not necessarily going to need to do the formal charge on B right off the bat because I see that that particular nitrogen has 10 bonds and nitrogen can't do that. So I'm not even going to bother to check that one. All right, but this is doable because octet rule is being followed by the nitrogen. Can't see my dots there. And D also has the octet rule being followed. So we're going to just check formal charges. And we'll start here on D. So I have a formal charge of this nitrogen of being -1, formal charge of that nitrogen being +1. And there's nothing I can do to make that better. I can't share the electrons between the nitrogens because then I'd have one of the nitrogens breaking the octet rule, the one on the right. Yet if we check it, formal charges of that structure are all 0. That is the acceptable structure of hydrazine.